All right, so in lesson 6-3, we were talking about how if we have a parallelogram, then we can conclude that opposite sides are congruent. That is always the case whenever we have a parallelogram. So what is new in this lesson 6-4? That we are talking about what we call converse of that theorem. So each theorem in lesson 6-3 will have a converse, like a relative, in lesson 6-4. So, and how are they related? Well, one is the original statement, and here it is the converse of that. So, how, if you guys remember how I get the converse, well, now hypothesis is not going to be the fact that is a parallelogram. Hypothesis is going to be that if opposite sides are congruent, then that is a parallelogram. So we are switching hypothesis and conclusion. So understanding lesson 6-3 means basically that you understand lesson 6-4. You don't have to overload your memory because you know that that is actually the case, that there is a relative theorem in lesson 6-4 to each one of those in lesson 6-3. Okay, so that is one of those, but also I wanted to show you. So maybe I need to clear this off and let me do here and let me try to show you like each one of the theorems. So right here, you see that each theorem says converse of theorem 6-8, which is a theorem in the lesson before. Okay, so let's look at this one down here. So what else did we say? It was true about a parallelogram. We also said that, let me put it here, we said that consecutive angles, consecutive, so that means like imagine you're traveling from one angle to the other, like in a circular motion. Maybe it could be like clockwise or it could be counterclockwise, it doesn't matter. But when you're doing that, from A you go directly to B. So that is why they are called consecutive, because one angle is after the other when you go either clockwise or counterclockwise. Okay, so D and C are consecutive, C and B are consecutive. However, C and A are not consecutive, because after C you do not go to A, you actually pass by B. Okay, so we said, well, if you know that the quadrilateral is a parallelogram, then you can always conclude that any two consecutive angles will be supplementary. And what does supplementary mean? That means that their measures add up to 180. So A and B, or also B and C, or also C and D, their measure will always equal to 180. Okay. So now what is new in this lesson? Well, in this lesson, we are saying that we can use that theorem backwards, meaning we can use the converse of that theorem. And what is it? Now we are switching what here in lesson 6-3, this was conclusion. And all of these was no, sorry, that I this is now the conclusion. This is now the hypothesis. But in the lesson before, it was all the way around. This was the conclusion, it was the hypothesis, and this was the conclusion. So now we are learning that we can switch those two to get what is called the converse, and that is also going to be true. Now, please don't think of that the reciprocal of any statement is always true, okay? Because that would be wrong. There are statements for which the reciprocal is not true, all right? So, um, you know, for example, if let's say that trying to think. Well, I will think of an example. I owe you one example, but please don't get into the idea that every single time you do the converse, if one statement is true, the converse is also true. All right, don't put that in your head, because although this is the case right now, it is not always the case. Okay, but in this particular example, we can say that. So we are going to use that, and I'm going to clear this off again. And I want to show you the other theorem, because those are the, like, so far, the two conclusions that we have from last lesson. But I want to show you, like, theorem by theorem right here, the converse of 6-9. So, and the converse, so we're missing two, but you know, I will go as quickly as I can. So right here. So what else did we say? We said that opposite angles, such as A and C, and we said that opposite angles were the ones that were not consecutive. So if you're going around, first you start, let's say A, you go through B, and then you go through C. So those two are not consecutive, but they are opposite. And we said those two were congruent. That was true in a parallelogram. So this was hypothesis, and that was conclusion. And now is backwards. So remember, please, that that means the converse, and each theorem in, again, in 6-3 has a converse that is also true. And those are the ones we are using in 6-4. So in that sense, that's why I'm saying it's gonna be easy. So let me go to the next one. So here is 6-1, 6-9. So this is the other one. And I think after that will be done. So what did we say in lesson 6-3? If you have a parallelogram, that was hypothesis, then the diagonals bisect each other. And what does bisect each other means? That one diagonal divides the other one into two congruent parts. So for example, AC, let me use my drawing tool right here. So AC divides this, maybe I'm gonna do it in another color. So AC divides, well, that is, if I could write, divides, oh my goodness, I didn't want to do red. So this, okay, blue. Okay, maybe now. So AC divides that diagonal in blue, diagonal BD, into two congruent parts. So that means that the distance from B to X is the same distance as the distance from X to D. All right, so if this is, let's say, 5 units, this is gonna be also 5 units. Kind of a similar thing happens vice versa. So now the diagonal BD bisects the other one. So I'm gonna do that in maybe, I don't know, let's say green. So BD is the one now doing the action over AC. And what does BD do to AC? Well, it divides that diagonal into two congruent parts. So if this distance from X to C is 6, then the distance from X to A must be also 6. All right. And what is new in this lesson? That your flipping around hypothesis and conclusion. So if you know that this is true, then you can jump in to conclude that that is a parallelogram. Okay. So main idea, I think I've said that I don't know how many times, okay, is if you followed 6-3, then you'll be easily done with 6-4 because those two are connected. So let me show you now what the IXL